Chapter 2, Polynomials. Okay, and before we start, we should have a good previous knowledge. So previous knowledge mainly these chapters. Okay, so I request you to read these chapters and make the previous knowledge clear. Okay, so we'll start with a general forms. After the general form, we can do general form. Okay, for a linear polynomial in one variable. Some example: 4x plus 3, 5x minus 4, minus 2x minus 3. So only one variable, so we can choose x. So can we give a general form for a linear polynomial in one variable? Yes. P of x is equal to general form.
Ax plus b.
Ax plus b, very good. X plus b, where x is the variable and a and b are constant. A and b are constant, and not constant term, constant. Okay, a is the coefficient of x and b is constant term. Okay, so here in a polynomial, the coefficients and the constant term will be a constant. And in this polynomial, 4 and 3 are constant and x is a variable. X can take any value. You know the difference between variable and constant. Usually we take A, B, C letters, small letter A, B, C to denote constants. So P of x is equal to x plus b is the general form of a linear polynomial. Okay. A second question, a quadratic polynomial. How we can write the general form? A quadratic polynomial. How we can write?
X square plus by
X square plus bx
plus bx is equal to plus c.
Plus c. Yes. Ax square plus bx plus c is the general form of a quadratic equation, quadratic polynomial. And we have next cubic polynomial. How we can give the general form?
X cube plus bx.
x cube plus bx square plus
bx square plus
d.
c. Cx plus okay. Ax cube plus bx square plus cx plus d is the general form of a cubic polynomial. Okay, so you know the general forms. And next one is okay. Next, two important theorems you have studied in 9th standard. Now, one theorem is remainder theorem. Remainder theorem. You know remainder theorem? Remainder theorem, you know. Two theorems are the remainder theorem and factor theorem. Factor theorem. So, remainder theorem. Okay, so look, if P of x is a polynomial, and if you divide P of x by x minus a, where is a is a real number, then P of a will be the remainder. Okay, if you divide P of x by a linear polynomial x minus a, the remainder will be P of a. Okay, if you divide a polynomial P of x by a linear polynomial x minus a, where a is a real number, then the remainder you get will be P of a. Got it? Okay, so this is called the remainder theorem. Okay, for an example, x minus 1 into. Okay, what would be the answer? If you multiply this, x cube minus 9. So I give name P of x is equal to x cube
Minus x squared.
and if you divide this this polynomial by x minus 1, what will be the remainder? If you divide x cube minus x square by x minus 1, what will be the remainder? So by applying this theorem, you can say P of 1. P of 1 will be the remainder, and that will be, here in this situation, it will be 0. Okay. If you divide any polynomial, suppose need not be 0. For example, suppose P of x is equal to 4x cube plus 3x square plus 5x plus 1 or something. We want to find the remainder when we divide it with x minus 2. So you don't have to divide by the division algorithm. You only need to find P of 2. Okay, if your question is only to find the remainder, you can simply do P of 2. What will be the P of 2 here? You know how to do this, right? P of 2, if P of x is equal to 4x cube plus 3x square plus 5x plus 1, what will be P of 2? 4 into 2 cube plus 3 into 2 square plus
5 into 2.
5 into 2 plus 1. So this will be 4 into 2 cube. 2 cube is 8. Right, so 4 into 8. 32 plus 3 into 2 square.
12.
12 plus 5 into 2.
10
plus 1. The sum is
65.
55. Okay. So this is the application of this theorem. So if you get a polynomial, you want to divide this polynomial with another linear polynomial. The first one can be any degree, but if you divide it with a linear polynomial, the remainder you can find out in a simple way. You don't have to divide as the division algorithm. It takes a lot of minutes, but you can simply calculate P of 2. That will be the remainder. Okay, that's what the remainder theorem says. If you divide P of x by x minus a, the remainder will be P of a. If you divide the same polynomial, this P of x by x plus 3, what will be the remainder? How can we find? I'm asking not the numeral value, but how we can find it? If you divide this polynomial by x plus 3, what will be the remainder? How we can find it?
X minus 3. Minus 3.
No. Here the remainder, in the first example, the remainder is P of 2.
P of 3.
P of 3 is wrong.
P of minus 3.
P of minus 3 is fine. P of minus 3. Here you look, for x minus a, if you divide with x minus a, the remainder is P of a. The theorem says so. The theorem says that if P of x is divided by x minus a, and the remainder is P of a, we have to take the opposite sign. Okay, so here P of minus 3 will be the remainder. Okay, I hope you got the idea of the remainder theorem. Okay. Our next theorem in 9th standard was the factor theorem. Factor theorem. Can anyone explain it? Factor theorem. So P of x is a polynomial. X minus a is a divisor. Then x minus a is a factor. If there's two parts for this theorem. First part, if x minus a is a factor of P of x, then is a factor implies something, and just a reverse also. For a polynomial P of x, if x minus a is a factor, which gives what information? If x minus a is a factor of P of x, then the factor theorem says that
P of a is equal to 0.
P of a is equal to 0. Very good. P of a is equal to 0. Okay, the factor theorem says like this. If x minus a linear polynomial where a is a real number, is a factor of P of x, then P of A will be 0. That's the remainder you got by dividing P of X by X minus A will be 0, right? If X minus A is a factor, then if you divide P of X by X minus A, the remainder must be 0, right? And by remainder theorem, we know that if you divide P of X by X minus A, the remainder will be P of A. So it must be 0. Okay. Then you can say the reverse also. If P of A is equal to 0, which implies what? X minus A is a factor. Is a factor. So you can say the reverse also. So X minus A is a factor implies P of A is equal to 0, and P of A is equal to 0 implies X minus A is a factor. Got it? Okay, so two theorems, remainder theorem and factor theorem. Okay, and next one, here we told P of A is equal to 0 and X minus A is a factor. So P of A is equal to 0 means there is some other idea. We'll come to that. I will start with a linear polynomial. So I give you an example, 4x minus 8 is equal. So here what will be P of 1? Can you do in your mind? P of 1. P of 1 minus 4, okay. And what will be P of 2?
0.
0.
0. Very good. 4 into 2 is 8. 8 minus 8 is 0. P of 2 is equal to 0. In such situations, if you give a value for x to get the polynomial value as 0, we call 2 is the 0 of P of x. 2 is the 0 of this polynomial. Okay. I give you one more example, Q of x. Q of x is equal to 2x, 2x plus 4. 2x plus 4, which is the 0 of this polynomial. 0. Minus
P of minus 2.
P of minus 2. So 0 is minus 2, right? So what value you should substitute for the variable to get the polynomial value 0?
minus 2.
Minus 2. So Q of minus 2 will be 0. Therefore, we can say minus 2 is the 0 of this polynomial. Okay. One more example. So R of x is equal to 3x minus 9. Then what will be 0 of this R of x? 0 of this R of x.
3.
0 is
Minus 3.
3 or minus 3?
3. 3.
3. So 0 of this R of x is equal to
3.
3 plus 3. Okay. So you know the idea of 0. So one thing we have studied in last lesson, how many zeros are possible for a linear polynomial? Maximum how many zeros are possible? 1. For a linear polynomial ax plus b, the number of zeros possible is only 1. Okay. Maximum is 1. And for a quadratic polynomial, x square plus bx plus c, how many zeros are possible? 2 zeros are possible.
2.
Yes, 2 zeros are possible. Okay, for example, I give you a simple p of x is equal to x square. P of x is equal to x square minus 4. So, which two are the zeros of this polynomial? This is a quadratic, right? This is a quadratic. So, which two are zeros of this polynomial?
2 and minus
2 and minus 2, very good. 2 and minus 2 are the zeros of this polynomial. Okay, and there is a relation between the zeros and the constant terms a and b. The a, b and 0, there is a relation. So you have studied that. So suppose this your polynomial to get 0 value. So the x plus b should be 0. So x will be minus b by a. X should be minus b by a. For linear equation, not quadratic. For linear polynomials, there is a relation between 0 and the coefficients. So in this example, so here 8 by 4, that is equal to 2, right? And in this example, here 4 by minus 4 by minus b by a. And here b is 4 and a is 2. So minus 4 by 2 is equal to minus 2 is the solution. So there is a relation. I am winding up. So here there is a relation between the coefficients and the 0. And in this chapter, in 10th standard, we will look at how is there any relation in quadratic polynomials, the coefficients and the 0 of the polynomial. Okay, and we will also discuss, as I showed in this picture, in this presentation. Okay. We will also discuss the geometric meaning of 0, and we will also do the division algorithm. You have started division algorithm in 9th standard. Today we didn't get time to reach there. So you have to revise these all topics. These are previous knowledge. Okay. We have discussed a lot today. So those all are previous knowledge. So you have to revise it very well. Okay. Revise all the previous knowledge so that we can learn this chapter easily. So we can wind up now. I wish you a nice day. See you next time.
Thank you.